Hello everyone, my name is Ashish Mohan and today I am going to demonstrate my project titled Meteor Strike Monitor. This is a Python based application and let me show you with a basic overview of the code. So this is my code actually, and you can see that I have imported some of the Python libraries. The whole code is actually based in Python and I've used all the Python libraries like Tkinter. Tkinter is used to make the GUI and I've imported typing for dictionary, list and union, and also date and time, os for os and csv for importing my csv and reading my csv file. You can see the overview of the code, but before that, but let me show you my running code. When I run this code, you can see that this box will pop up, and as you can see there are some of the options like load csv file. I've already, when you click on this will be shown and you can click on data. Like I already selected my meteorite landing. I selected it and then opened it, and as you can see I got this result. And on second you can see the apply filter. This filter will apply, like when I will write 2012 and apply this filter, you can see that I am getting this data about all the meteorites by threat level, mass and class of all everything that happened, everything that we have captured in 2012. And if I clear this filter, you can see that everything is back to normal. We can also sort this by mass. Here when I sort this by mass, then we can see it has been arranged according to the ascending order, and you can see as we go down the mass increases, the threat level. As you, there is also correlation between mass and threat. The greater the mass is, the higher the threat is. If anything that exceed the mass of 1 kg, that will be in threat level medium. Below that everything is threat level low. Because to give you the context, that when a meteorite strikes in the atmosphere, it burns actually in the atmosphere. If the meteorite is very small, it, and the element which is made up of is also not very strong like iron, it is not iron, then there is a chance that due to the speed and friction in the atmosphere, which may exceed to 152 kilometers per second, in astronomy we call it meteorite bursting. So that will happen in the atmosphere, and the meteorite will burn in the atmosphere itself. But some, as the mass increases and the size of the meteorite increases, there's a chance that the whole meteorite won't be able to burn, and there's a chance that it may fall on earth and may cause severe damage. Because you can just imagine that something moving at a speed of 150 kilometers per second hit you. That would be devastating. And as we, like, let me clear this also. There's also this short by ear, and short by ear you can see that there is also I have anything above, to give you the context, that anything above 10 kgs is a high level threat, because there's a very high chance, very high chance, that it will fall on earth and it may cause a severe damage. And this was all for this GUI. And in the end I want to show you this show stat. This is the summary of the whole data that I have collected. For example, the meteor, this is the total number of meteorites. The total data we have, that is 45,716. And then we have mass statistics like average, maximum mass and minimum mass. Like you can see this, I have did this in the bottom using this, like this function max, sum and min function. I've done this using this. And there is threat level. Like we have low level threats, 89% of them are low level threats, medium threats 7.6%, and high threats 3.0%. And that was all for my project overview, and thank you for watching.